Hey everyone, we are back and we are going to look at chapter 1.3, which is about, it's called the 12 basic functions, but there's actually more to it than that. Oops, let me share again. I did that wrong. Stop. Thank you very much. Do it. There we go. That's the way I want to do it. Make that go away. There we go. So I'll put me right there. So there's 12 basic functions that we'll look at that you need to be able to identify by sight, and it's not very hard. Some of them are not very important. I'll show you what those are. But before I do that, and these are all in the book in chapter 1.3 with very pretty diagrams that are easy to see. So they're easy to find. But before we do that, I want to talk about something else. We need to have a talk. Okay. Now, functions, there's really three kinds of functions. So, right, we kind of talked about even and odd functions before. Whoops. Let me turn on my, where's my pen? Oh, I got to fix that. Hold on. This thing tells my drawing tablet which monitor to use, and I want to use that monitor. Okay. Now we're cooking with gas. Okay, remember, there's even functions. Oops. And there's off functions. Yeah, that's it. Odd functions. And let me just pause. Okay. So there's even and odd, and you remember for even functions, f of x equals f of minus x. And for odd functions, f of x equals minus f of minus x. Now what this means in terms of a graph is, oops, that is a pretty terrible axis. It's like a drunk axis. So if you had something like that, there we go, beautiful. And here's f of x, and here's x. So here's x over here, and here's the value f of x. Basically, the y coordinate is f of x, because this thing is equal to the y-axis right here. So when I go and I find minus x, it's an even function if when I go and find it, I hit the same point again. Oops, I kind of missed because I didn't draw it right. But if I'm at the same point again, if my y value is the same for f of x or f of minus x, then it's an even function. And that is also equivalent to saying if I fold it down the middle and I just take it and fold it, will it line up on itself? And that's another indication of an even function. Now, if I have an odd function, oops, a thing like this, I just ruined the surprise. Darn it. Okay, so this is f of x, and this is x. And I go over here and I find a value x, and I go down, oops, go down, and here's my number f of x, which is equivalent to the y coordinate. I got some negative number, right? Because it's down here below the x-axis. But if I go to minus x, and I go up here to here, well, if that's up at plus y, then f of x is going to give me y. F of minus x gives me minus y. I get f of minus x is going to be, this is going to be the negative of this. So this answer, f of x, and that answer, f of negative x, the only way to put them equal is to slap a negative sign somewhere so we can cancel out this negative sign right here. So this is what looks like an odd function. So if I fold it onto itself, you can see both halves are not going to line up because this other half is down here. But if you took one side. So if I took this bottom part here, if I took this part right here, and I did a flip, and I flipped it vertically, then I could fold them over and they would line up. So this is an image of an odd function. You flip them, they don't line up, but if I do a vertical flip of one side, then they will line up, okay? Even and odd. So this is what we want to look for our functions. If we had something that was like that, well, there's no way you're going to flip that, or you're going to flip one side and then flip them. This is never going to line up. This is neither. Okay? Neither, neither, neither. Okay. So now let's look at our functions. So let's see, how do we do that? I'm going to go to here. No, I don't want to go to there. I want to go to here. And oops, screenshots. So here's the first two. There we go. This is the identity function, y equals x. Let me annotate, right? So y equals x. This is a line y equals mx plus b, where the slope of the line is the number right in front. So the slope is 1, and the y-intercept is the constant over here. The y-intercept is 0. So it just cuts through here at an angle of 45 degrees because x and y are exactly equal. Okay? That is the first function we have. Let me move this thing. Come on. There we go. It's kind of hard to move sometimes. Okay. Second one, the squaring function, y equals x squared. So this is our second type of function. You go over 2 spots, you go up 4 because it's y equals x squared. Okay? So this is a parabola. Okay, so now let's look at the next one. Numbers 3, 4, 5, 6. These are not numbered in any specific order. The cube function, y equals x cubed. So you'll notice, first of all, oops, sorry, stop. I don't know what's going on there. Let's stop that. Let's close it and open it again. Oh, so while we're here, so notice if I go to flip the first function, if I go to flip x and y, it doesn't work. I don't get these things lined up. But if I take this piece and I do a reflection around the x-axis and I get it to be there, now when I flip it, they will line up. And if I also look at when x is 2, I get 2. So f of 2 equals 2. When I try f of minus 2, what am I going to get? I'm going to get minus 2. Whoa, look at that. F of 2 is equal to minus f of minus 2. So this is the definition of an odd function. Okay, that's an odd function. But then if we look down here, if I pick x equals 2, I'm going to get 4. If I put x equals minus 2, I'm also going to get 4. So f of 2 equals 4, f of minus 2 equals 4, so f of 2 equals f of minus 2. That's the definition of an even function. And it can be folded onto itself. So even, even, even. Now let's go back to here and let's open up that one. So now this one, f of x equals x cubed. If I choose, I don't like to test with 1 because 1s do funny things. Like I don't like to test with 2s or like with 0s, but I like to test with 2s. So f of 2 is going to be 2 cubed, which is 8. So that's going to be way up here somewhere. F of minus 2 is going to be minus 2 cubed. It's very important you write the parentheses because you're putting minus 2 into this cubing function. That negative sign has to be cubed as well. And since it's an odd power, the negative sticks around and we get minus 8. So f of 2 is equal to minus f of minus 2. I got to have a minus here to get rid of that negative so I can set these two equal to each other. So this is an odd function. And again, if I take this half and I flip it vertically, then they will overlap. Okay? Okay, this next one we talked about when we were talking about asymptotes. Here's y equals 1 over x. So as x gets close to 0, these functions shoot up towards infinity and down to negative infinity. And when I do f of 2, let's say, I'll get 1 over x, 1 over 2. If I choose f of minus 2, I'm going to get minus 1/2. So again, these are an odd function. And again, if I take this piece and I reflect it about the x-axis and stick it up here, now they're going to overlap, except for my terrible drawing. Okay? The reciprocal function, 1 over x, is an odd function. Now, square root function, this is a funny thing, because remember we talked about this when we talked about functions of it being plus or minus x, and if I include this bottom half, it fails the vertical line test and it's not a function because this value of x would give me 2 values of y. Square root of 16 gives me plus or minus 4. That makes it not a function. So if I want to use it as a function, I have to restrict it and say use no y has to be greater than or equal to 0. Can't choose, we can't take negative values. So this one, there is no value over here because we can't put, if we try f of 2, we get square root of 2. If I try f of negative 2, square root of negative 2, well, that just makes me sad because that's not a real number. This will be an imaginary number and we're plotting it on the real plane, so there is nothing out here. So is this one even or odd? Well, it doesn't satisfy the even test. F of 2 does not equal f of minus 2, that is for sure. And it also doesn't satisfy the odd test, minus f of minus 2. That is not true either. So the squaring function is neither. It's neither even nor odd. It's just its own little deal there. Okay, e to the x, the exponential function. We're going to talk about this a lot this semester. And if I look on either sides, there's no line of symmetry. You can see there's a line of symmetry here. There's a line of symmetry here. There's no line of symmetry here. So this has no symmetry to it. So there's no way I can look and see if I can fold it onto each other, or can I do a flip on one side and then fold it onto it? You can't. There's nothing here. And if I try f of minus 2, oh, by the way, e is just a number. It's an irrational number. 2.71 dot, 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 dot. It goes on forever. I don't know what all the decimals are. I remember it to 2.71 because that's good enough for me. So it's just a number. It's not a variable. E is a number. E is a number. E is a number. Don't let it freak you out. So if you're going to do square root of 4, you'll get something. Well, square root of 5, you'll get something and you'll punch that into your calculator to see what square root of 5 is. If you do square root of e, well, you're going to put in square root of, either you're going to plug in 2.71 or you're going to find the e button on your calculator and you're going to put an e here. It's just a number. It should not freak you out at all. Okay? So let me get rid of all that. Okay, so over here, f of minus 2, f of, whoops, what am I doing? I'm going to start over here. So if I test this to see if it's even or odd, f of 2 will be equal to e squared, 2.71 blah, 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 blah squared. F of minus 2 will be e to the minus 2, and a negative exponent can put something into the denominator. E squared is the same as e to the minus 2. The negative in the exponent means move that thing down into the denominator. So I'm going to go out on a limb and say this is absolutely not equal to that. And if you put a negative, there's no relationship here. These are not equal. They will never be equal because there's no line of symmetry here. This is an asymmetric kind of curve. So this is neither even nor odd. Okay? Any questions? I like saying that. Of course, there's no questions. You can't ask questions, but you can come to office hours and ask for questions. Good idea. Okay, let's see the next one. Okay, natural log function. Natural log, we'll talk about this later. I won't talk about it now. You may have studied natural log in high school. But natural log function looks like the whoops, dang it, I did it again. Am I even sharing? I'm not even sharing. Okay. So you didn't even see what I did. Okay, there we go. Okay, so the natural log function goes up like this, or the e to the x function goes up like that. Natural log function goes like this. Neither of these have a line of symmetry. Neither of these are even or odd. But we will talk about natural log a lot later in the course. So fear not. I don't even know what this thing is. Anyways. Okay. Sine, we'll talk about sines and cosines, but sine is this oscillatory function called the sinusoidal function. And if I do sine of 1, I'm going to get some number there just below 1. If I do sine of negative 1, it looks like I'm going to get the same thing but negative. If I flip this, if I reflect it around the x-axis, it's going to look like that. And now both sides are going to be equal. Now I could flip it and they will line up with each other. Sine is an odd function. Some things about sine, which we're going to talk about later, but it always repeats itself right here at, that's where one cycle ends at 6.28 or at 2 pi. So it goes from 0 to 2 pi and then it repeats itself. So it goes 0 to 2 pi, then it goes zoop from 2 pi to 4 pi, and then it'll go again zoop from 4 pi to 6 pi. 2 pi is its period. That's how frequently it repeats itself. Okay, next one. Oops. Come on. Yeah, we do it this way. Uh-oh. There we go. I just learned that trick on the Mac. I hate it when that bottom bar moves to another monitor. It drives me nuts. Okay, so cosine is like sine. It's an oscillatory function. It repeats every 2 pi. And then it'll go along and it'll repeat. Next one's going to end at 4 pi, blah, blah, blah. Notice that this one has a line of symmetry, and the cosine of 1 and cosine of minus 1 are going to give the same value. Cosine is an even function. Okay? Absolute value. If I put y equals absolute value x, if I put 2 in here, well, I'm just going to get 2 because there's no negative. If I put negative 2, it's going to give me positive 2. This is an even function. You can see the line of symmetry, and if you fold it, it's going to line up. Even. Okay. The integer function. This is not something we're going to use very much at all. Something you'd use in programming a lot. If you have a number and you want to convert it to an integer, you type int and then your number, and it will spit out 6 in this case. And you can set this to be either it rounds or it truncates, which means chops off the decimals. I think the integer function in programming usually truncates and throws away the end. I don't know. I'm not much of a programmer. But anyways, this thing looks kind of like an odd function, right? Because if I choose, let's go to 2. If I go to x equals 2, I get this point up here, 2. If I go x is minus 2, I'll get minus 2 down here. So they're negatives of each other. The greatest integer function is odd. And again, if I take this and I mirror it around the x-axis, it's going to look like this. And now they will overlap when I flip them. Okay? Okay, the logistical function. This is something that's used in business statistics that I don't think we're going to touch this at all in class. But you can see if I choose 2, I'm going to get a number close to 1. Maybe it's, I don't know, 0.8. If I choose negative 2, I am not going to get 0.8, and I'm not going to get negative 0.8. I am going to get nothing. So this thing is neither even nor odd. And this is what the function looks like. And I don't think we use it at all unless we just do some kind of homework problem with it. But I don't think we'll use this at all. So those are the 12 functions. And those are the things that you want to be able to look at and be able to identify which one it is. Because we're going to do things like translating them, not putting them in different languages, but moving them. So let's get rid of that. So if I have y equals x squared, so this is a parabola, centered at 0, its vertex is at 0, right here. We'll talk about conic sections and the focus and the directrix and all that kind of happy stuff. But here's what it looks like. But if I do y equals x plus 3, what's that look like? Well, let's go to my little friend. Oops. Symbol Lab. Okay, and I'm going to go to the graphing calculator, and I'm going to put in x squared. And over here, I am going to put in x plus 3, and go to the outside of the parentheses and put my square. Oh, look at that. The pink one, y equals x squared, is centered right at 0, 0. But this one has been shifted over negative. It's been shifted 3 units to the negative direction. Huh, that's interesting. This is a positive. Oops. This is a positive right here, but this has been shifted in the negative direction. I wonder if that's a coincidence. I don't know. Okay, let's try another one. Let's go. Oops, gotta turn off my drawing thing. Let's do x minus 5. That'll be fun. Oh, yeah. Oops, I can't do that. Sorry, I gotta do that. I always forget. Why can't I drag it down? Okay, so let me get my annotation thing and clear them again. So this one said a plus 3, and it shifted negative 3 units. This one says a minus 5, and it gets shifted a plus 5 units. So this is referred to as a translation. And when you translate something, the rule is that when you translate, you always, whatever this is, translate opposite from the sign. Now this is true when it's in parentheses and the exponent function is acting on it inside the parentheses. Okay, so if I ask you, describe the translations for y equals x minus 9 squared, you would say translated 9 units in the positive direction because it's opposite from the sign, opposite from the sign. So that's a positive 9 translation, translating 9 units to the right, translating 9 units in the positive direction. That's the same thing. But what if I add a plus 6? What's that do? Well, let's see, this is different. This thing originally, let me, oops, make that go away. Okay, where's my eraser? Okay, that went away finally. Okay, so if I get rid of that, that's not going to work. There we go. Okay, so if I do x minus 9, that's going to be, oops, a pen, a graph, 1, 2, 3, 4, 5, 6, 7, 8, 9. That would be like this. I want to draw that. I know it's silly, but I want to try to be good about my colors. Okay, so that would be something like this. Oh, that's terrible. Something like that, okay? Where it hits right here at 9. But then if I add, so this whole thing here gives me this whole thing gives me the y coordinate, right? Because it says it's equal to y. So this function spits out the y coordinate. So if I go to a number, I don't know, x equals 12, I can do 12 minus 9. So that's 3. 3 squared is 9. So it's going to be up here at 9, right? This function gives me the y coordinate. But now if I add something to it, plus 6, well, this still gives me the y coordinate, but then I have to add 6 to it. So instead of being here at 9, I have to be here at 15, way up here. And in fact, if I put 9 in here, if I choose the vertex without, how can I do that? Without this being here, when I put in 9 into here, 9 minus 9 is 0. I get 0. That's what it means to be the vertex. That when I put in this value, I'm going to get y equals 0. But when I have plus 6 here, if I put 9 in here, 9 minus 9 is still 0. Squared, still 0. Plus 6. So now my vertex is going to be up here at 6. The whole curve is going to get moved up. So this kind of translation is a vertical translation. And this one is the same direction. So we're always going to solve these for y. We're going to put this number over here, and this is going to be the vertical shift, same direction as the sign. Okay? Always same direction of the sign. This one, always opposite direction from the sign. Because it's inside the function, it's stuck inside here, and it's being acted on by the function. Opposite from the sign, same direction as the sign. This is something that people get confused, so don't. Oh, I got more stuff there. Let's see, how do I get rid of that? There we go. Okay, so there are questions that ask for f of x equals ln x plus 2. The natural log function, when you look at the sheet of pictures, that are in the book, at the beginning of chapter 1.3, you'll see the natural log function looks like this. What does the x plus 2 do? And by the way, it always goes through the natural log, we'll learn later, always goes through the 0.10. But x plus 2, it's going to shift it 2 units. It's inside the function. It's going to be opposite. So it's going to go 1, 2 units over here. The real function with the phase shift, with the shift, is going to be like that. And now this point is going to be, it's at 1, 0, minus 1. That's it, minus 1, 0. It's going to shift it over 2 units. So looking at this, we need to identify what kind of translation it is. Okay, y equals x minus 2 cubed plus 5. What kind of translation does this have? Opposites from the sign. I don't really care what the function is. I'm just looking at what we do to it here. I know this is comparing to y equals x cubed, right? It's this function from the set of 12, but we're moving it around on the page. So minus 2 is going to be a plus 2 shift, plus 2 horizontal shift, and it's going to be a minus 5 vertical shift. Okay? So should look at these. If we have something like y equals 3x squared, this would normally give us the x coordinate or the y coordinate. We put our x in here, x squared spits out the y coordinate. That's what the normal function would do. But what's the 3 going to do to the answer that comes out of x squared? So if I put 2 in here, 2 squared is 4. That's what we'd normally expect. Here we go. 2 squared is 4 times 3 is 12. So here I would have gotten y equals 4, but here I'm going to get y equals 12. So when I put a coefficient out front, this becomes a vertical stretch. A vertical stretch of 3. Or it's going to get 3 times bigger, 3 times taller. So it's going to stretch the curve straight up. And we can see that on, I get rid of that, and I put 3x squared. So it looks like it narrows it, but really what happened was the point that was right here, whatever point I would have gotten for, what is that, 1, 2, it's 4. 4 squared is 16, so I'm up here at 16. Really, it's 3 times bigger, and it's way up here at 48. So we took that point that we would normally get with the normal x squared function, and we stretch it way up here. So that's a vertical stretch, okay? So I think that's it for those. Let's look really quick. The bulk of the chapter is identifying what kind of function it is. There's a bunch of stuff about piecewise function. We're going to worry about that later. So that's about it. So look at the homework problems. During the class session, I'm going to be doing sample homework problems. So if you have trouble on the homework, you should come, and I will do problems that are similar to the homework, but not the same as the homework. So I encourage you to come to the office hours or class time and see that, so I can help you with the homework so you can be successful. And then when we have a quiz, you'll know exactly what to do and you'll ace it. Hooray. Okay? So we'll see you later. Bye.